Today we're doing 3.4 over quadratic graphs. For this one, we're given a standard form, which is y equals ax squared plus bx plus c. And we're given these two formulas. So for vertex, we're going to have to do negative b over 2a. And this looks really crazy, but basically you take your answer here and plug it back in for both x's into that equation. That gives you your vertex, which is that highest or lowest point on a graph. And we're going to do all those things with our example over here. There's also something called the axis of symmetry, and that is going to be found by x equals negative b over 2a. So the same formula for that standard form. If we look at this example, we have our a value is 3, our b is negative 12, and our c value is 17. By taking those and trying to find our vertex and our axis of symmetry, which I am about to abbreviate as AOS, for axis of symmetry. So if I look at that here, my axis of symmetry is x equals negative b over 2a. And I'm going to be plugging in those two values. So my b value is negative 12, and my a value is 3. Well, minus a negative is going to turn it to a positive 12 on top, and 2 times 3 is going to equal 6 on bottom. So my axis of symmetry is actually x equals 2. Now that I know my axis of symmetry, in order to find the second half of my vertex, I then am going to have to plug it in for both of my x values. So I'm going to slide this all over. Here we are. We'll shrink it a little bit. Thank you. So to find my vertex, which I'm going to label up here, our vertex. Right now we know that the x value is 2, but we're still looking for that y value. In order to find it, we're going to take that orange equation. So y equals 3 squared minus 12 times our number. I need to move it a little bit more. And then plus 17. And I'll be plugging in our 2, which is our axis of symmetry, or the value we found by doing negative b over 2a. So we're going to get 3 times 4 minus 24 plus 17. So 12, we combine these, minus 7, we're going to get 5. So my vertex is going to be 2, 5. Axis of symmetry is at 2. Some of you may be wondering what type of graph this is. And if we're trying to graph this, I'm going to do a very rough sketch with just the key information that we found. So for that key information that we found, we know that our vertex is at 2, 1, 2, 3, 4, 5. 2, 5. And we know because it's a positive graph that the graph is going to go up like that. Now, our axis of symmetry being at 2 as well, that means it always goes through our vertex. And if we folded the graph on top of itself, it would be symmetrical. That's what this axis of symmetry means. So our vertex is at highest or lowest point, which for us is at 2, 5. And the axis of symmetry cuts that graph in half. If you're looking for a good website in order to graph online, because maybe you don't have a calculator yet, Desmos.com has a graphing calculator that is completely free, and I highly, highly recommend it. So let's look at another type of, another form of quadratic graphs. And for this one, it's going to be vertex form. Vertex form, here we'll move it right there. Vertex form is actually a lot easier. So for vertex form, we're going to get a completely different example. And let's say we have y equals negative 2x minus 3 squared, and we can just stop there. So let's say this is our example. In order to find the vertex, it's going to be the h and k value. There is a little caveat here. Whenever we're choosing our h, which in this case will be 3, that's my h, our vertex is going to be 3, and then there's nothing on the outside, so 0. That will be our vertex for this equation. That's it, because there's nothing out here. It's like a little plus 0. It doesn't matter. So the one thing that you do have to pay attention to is if it's a minus on the inside, it turns to a plus on the outside. Your graphing calculator or whatever graphing device you have will show you that it moves to the right 3, but that's just a transformation or rule of thumb. What I tell some of my younger students or people struggling with this is that if you've ever had a crazy x, your x always lies. So if you're trapped in the same room or same area as them, just know that they're going to tell you that they're going the other direction or they're lying to you. So a minus turns to a plus, or a minus represents like going to the right, which is opposite of what you think. Given our vertex, we can easily see that our axis of symmetry is just that x value, but we do have to write it as an equation. So it's going to be x equals 3 because it represents a vertical line on that graph. Hope this helps. Oh, let me pull it down in case you wanted to see all of it at once. There you are. I am sorry about the glare. Thank you.